Hey, College Algebra. In today's video, we're going to be talking about lines. You guys have seen lines from Algebra 1, Geometry, and Algebra 2. So we expect you guys to have mastered them at this point, but we want to start from fresh, get you guys to remember all the stuff about lines, and after this, you guys should be having it down. So let's get started. Okay, so let's talk about the slope of a line. And our slope here is going to be m. And slope is equal to the change of y over the change of x. And here's a picture to help demonstrate it. Just remember, so it's going to be rise over run. Okay. So let's find the slope through these 2 points. So here, let's label all these. x1, y1, x2, y2. Okay, so we'll have y2, which is -3, minus 5, which is y1, all over 4 minus -2. This is our slope. So we'll end up getting that this is -8 over 6. And if we reduce that, which is going to give us -4/3. And -4/3 is our slope. So let's look at our 3 different linear equations for lines. So here for the slope-intercept form, here we have y equals mx plus b, where m, which is what we looked at before, is our slope, and b is our y-intercept. Okay, let's look at point-slope form. Well, here we have our y1 and x1, and those are given to us by some point. We'll call it p. And that point is going to be equal to the coordinates x1 and my y1. And just as before, our m is going to be equal to our slope. And so there might be a question like, find the equation of a line given the point p and the slope m. And you can plug those x1s and y1s and that slope back into point slope form. Okay, and now let's look at the last one, general form. Here, we're just going to have some constant, some real number, a, and b is going to be another number, and c is also just going to be another real number. Okay. All right, so those are our 3 forms. Now let's look at this example. Find an equation of the line having slope -2 that passes through the point 1, -5. Okay, so slope n is equal to -2, and our point p is equal to 1, -5. Well, if we go back to our previous slide, if we look at our point slope form here, we notice that we're working with a point that has an x1 and a y1, and it has a slope. So let's go ahead and use that form. Okay, so we'll have y minus y1, which is here going to be -5, so we'll change this to +5, is equal to m, and our m is going to be -2, so -2, times x minus x1, which is just going to be 1. Okay. All right, so now we have put it into our equation form. But now we still need to graph it by hand. To graph it by hand, let's put it into slope-intercept form. And so if you guys remember, slope-intercept form is going to be y is equal to mx plus b. Okay, so to do that, we're going to subtract our 5 over and multiply by this -2. But first, let's just multiply by this -2. Or, sorry, let's distribute this -2 to the x and -1. So we'll do that. We'll get y plus 5 is equal to -2x plus 2. And we just subtract our 5 over, get y by itself. We'll get that y is equal to negative 2x minus 3. Okay, so here, our minus 3 is going to be our y-intercept, and here, our negative 2 is going to be our slope. Okay, so here we can count down negative 3, so y-intercept, and then we're going to have a negative 2, so we're going to go from high from the left, low to the right. So we'll go down 2, another 2, another 2. And we'll go up 2, so on. Okay, and so we graph it. All right, let's look at this other example. Find the y-intercepts and the slope of the line represented by this form. And this is going to be our general form. Because we have constant there. Okay, so in order to do this, it's going to be a lot easier to turn it into slope-intercept form. So let's go ahead and do that. And so we want to get into slope-intercept form, we subtract the 2x. And subtract the 2x because we want to get y by itself. So we'll have 4y is equal to 2x plus 8. All right, now let's divide by 4. Something by 4. And so we'll get y is equal to negative 1/2 x plus 2. Okay. So now we got in the point slope form. Now the question is asking us what is the y-intercepts and what is the slope. Okay. So here, if you remember, this is our m, which is our slope. So m is equal to negative 1/2 x. And our b here, b, is equal to our y-intercept. So b is equal to 2. And those are our answers. So let's go over two types of lines. First, we have vertical lines. And vertical lines are represented by going strictly only up and down. So just like this black one right here, or like this one right here. And those are represented by having x equaling to some number. So here, if we look at first line we drew, cross number 1, x is going to equal 2 no matter what our y value is. And so we'll have x is equal to 2. Let's look at our line number 2 here. So we count that over 1, 2, 3, 4, 5, 6, 7, 8. There, x is going to be equal to negative 8. Okay. Now let's look at horizontal lines. Okay. Horizontal lines strictly go left or right. They'll never go up and down. And so here are just two examples right here. Okay. And so to find the equation that goes with horizontal lines, and be like, okay, so this horizontal line is going to be y equals 3 for what, no matter what x you choose, like y equals 3 here and y equals 3 here. So our equation is going to be equal to y equals some number for any horizontal line. So here for this first one, or 1, be equal to 3. And for this horizontal line, number 2, we'll have y is equal to negative 4. Now let's talk about another two different types of lines. Let's first start with parallel lines. And parallel lines are lines that will never intersect each other. And so, drawing an example here on top of the graph, we'll have one horizontal line we'll have another one. And these two will be considered parallel lines because they'll never intersect and have the same slope. Let's look at another two right quick. One's that are horizontal. Let's look at a line that has a slope of 1. Now, a parallel line to that is going to be another line that also has a slope of 1, but we'll just have a different y-intercept. And as you guys can see, these lines will never intersect. All right. So when looking at equations, how do we know when lines are parallel? So when I was describing these two lines, they both have the same m. So this m and this m are equal. So here for the first one, we can say y is equal to mx plus some y-intercept. And here it looks like our first one, call this one line 1, is 12. And here, for our second one, we'll have y is equal to mx plus some y-intercept, which looks like it's 9. And so there we go. And so the way to tell if two lines are parallel is if they have the same slope. And if they do, they are parallel. Okay, now let's talk about perpendicular lines. Perpendicular lines are lines that actually intersect, but they intersect so that way there's a right angle between them. All right, so let's look at some examples here. Okay. So suppose we have this horizontal line right here. A perpendicular line to that is going to be a vertical line, because a vertical line is going to have 90-degree angle. Well, what's an example of two lines that aren't vertical or horizontal that are perpendicular to each other? So here, let's draw the line y is equal to x. Okay. Now I have to find some line that's perpendicular to it, so it has a right degree angle. And that line is actually going to be negative x. Okay. Well, why is that? Why are those two perpendicular? Well, let's go over a couple equations here. So here, we have y is equal to mx plus b. So to get the perpendicular line, what we have to do is multiply. We have to change the slope, this y2. We'll call y2 the perpendicular line. Its slope should be equal to negative 1 over m from the first one. So we'll have y2 is equal to negative 1 over mx plus some other b, plus b1, b2. Okay, so let's look at our example when our slope here, m, is equal to 1. Okay, so for our first line, we have y is equal to x. And so our y-intercept is just going to be the origin, so b is 0, so we just have y is equal to x. So what is the perpendicular line to this, or any perpendicular line? And so for here, we'll have perpendicular line y2 is equal to negative 1 over our m. Here our m is just 1. I'll write that x there. And it's just equal to negative 1x. And so that is going to be a perpendicular line. Now, a question to be asking yourself is, does y-intercept matter for perpendicular lines? Well, what if we drew a line like this that has the slope negative 1 through all this? So this is a line, y is equal to negative x. Well, here, you're going to end up with a right angle. And it's actually not going to matter what your y-intercept is. So here you'll have plus, or actually be minus because we're in the negative y. Be minus 1, 2, 3, 4, 5. It'd be minus 5. And so this line is also perpendicular. And so it doesn't matter what your y-intercept is. Okay, let's look at a question that involves parallel and perpendicular lines. So here we have find the slope-intercept form of the equation of the line that passes through the point 1, negative 3, and A, first part of the question, is parallel to, and B is perpendicular to. So let's go ahead and break this into two parts. A and B. Okay. So we need to find a line that's parallel to 2x minus 3y equals 1. Now, if you remember from the last slide, every line that I was working with was in slope-intercept form. So here, we should do the same and get y by itself. So we subtract 2x, subtract 2x. Okay, now we just divide negative 3 by negative 3. We'll get y is equal to negative 2/3. Should actually be positive because it's two negatives divided by each other. Minus 1/3. Okay, so we got it into slope-intercept form. All right, so now remember, for parallel lines, our slope doesn't matter. Our slope is always going to stay the same, but our point B is going to have to change. And so let's write down our point down here. So point here, P is equal to 1, negative 3. And so we'll write negative 3 in for y. Negative 3 is equal to 2/3. Remember, our slope isn't going to change. X, which in this case is 1, minus b, or plus b. Okay, now we have to solve for b. All right, so we subtract the 2/3. Subtract the 2/3. We'll end up getting that negative 3 2/3 is equal to b. And if we were to write this out into the straight fraction form, we end up getting that 11, negative 11 over 3 is equal to b. And so our final answer is going to be y is equal to 2/3 x minus 11 over 3. All right, so now let's look at a perpendicular side. Okay, so first, gotta do the same thing, put into... All right, sorry about that. I had to pause the video because the bell was ringing, and yeah. So anyways, here for part B, when we're talking about perpendicular lines, we have to use the point-intercept form again. And so I'm just going to write it down from when we solved it right there. So if y is equal to 2/3 x minus 1/3. All right. Do you mind if I shut that door? Sorry about that. We got to shut the door. Okay. Now, after those two interruptions, let's get started again. So now that we're looking at the slope-intercept form, let's go ahead and find the perpendicular slope. What does the perpendicular slope need to be? So to convert this slope right here, at 2/3 into a perpendicular slope, we have to do negative 1 over what our m was. This is being our m, over 2/3. And well, this ends up being -3/2. And so this is going to be your slope for a perpendicular line. All right, so let's go ahead, write that out. Okay, now the only thing we have left to do is solve for b. Remember that our point P is equal to 1, -3. So let's go ahead and put in all of our x and y values. So when we do that, we'll have -3 is equal to -3/2 times our x, which is 1, plus b. All right, so now let's go ahead and add our 3/2 over, or we'll add 3/2. Add 3/2 over here. And so we'll get b is equal to 1 1/2, which ends up equaling 3/2. Okay, and so that's our b. Now all we have to do is write it in slope-intercept form. And so we'll get y is equal to, we look at our perpendicular slope, -3/2 x plus our b, which is 3/2. And that ends up being perpendicular slope, and this from before was our parallel slope. All right, so you guys have 2 more questions to bring into the class tomorrow. Please bring your solutions. It's going to be a great extra practice for you guys. Yeah, and then we'll see you guys tomorrow.